Bailey Ambrose Heller is a mechatronic artist combining his passion for robotics with the artistic process. He graduated from the University of Washington with a degree in mechanical engineering and a minor in digital arts and experimental media. Bailey aims to use technology to reflect aspects of humanity and people's relationship to automation and artificial intelligence. Without further ado, please join me in welcoming Bailey Ambrose Heller. Thank you.
Hello, everybody. I'm Bailey. I'm really glad that worked. So this is Wiley, he weighs 48 pounds, which makes him really hard to carry around. And he has 10 motors, not including the fans. He has full control of his arms and his head and his tail. And there are 2 Raspberry Pi computers, which are basically computers that don't have screens at the moment. And there are many different integrated circuits on this side here, and the goal was to kind of present that to the world, kind of instead of hiding it inside of a black box. So for inspiration, maybe you're familiar with these Boston Dynamics spot robots. They're these robot dogs that try to come across as kind of cute, but often are a little creepy. And that's what I was going for with this, is kind of a creepy version or maybe an unfiltered version of these robots. And you can see it has this wear on it, and I wanted to make it look like this is a robot of the real world, or maybe a robot that we don't see in the real world because robots aren't as presented in our lives as science fiction made us think that they were going to be at this point. Another point of inspiration was like excavators and tractors, because I remember when I was younger, whenever I would look at an excavator, I would see a robot. I would see an animal that was digging, and if it was a good operator, it seemed like fluid motion. And you might be able to see that its head is very tractor-like. These are the treads. So the black box, that's the title of this, and he came out of a literal black box. So the black box in the terms of mechatronics applications is the point at which a piece of technology becomes almost magic to you. So your phone, the black box, is very much behind the screen. We touch the screen, and then we assume the outputs. We know what's going to happen from the outputs, but in no way do we know what's actually happening inside of the black box. And then the same goes for this. You might have watched that performance, and you might have been thinking about what it was thinking and how it was making the decisions it was making. And I think that shows the power of the black box and how, depending on like how much you present to the world and how much you're willing to be forthcoming of what's actually going on the inside of this machine, you're able to imbue your own imagination onto what's going on in its brain. So Scratch Night was now 3 months ago, I believe, and here's where I was that night. I had a couple sketches of the kind of robots that I wanted to make. I know I wanted to make a robot that kind of went around the stage, and I was originally making like meerkat robots, very cute robots, and I think those are very fun, and we see those a lot in like media. But then I had the alternate idea of more of a monster-y robot. And I think the power of fear, especially in technology and AI these days, I think is very powerful, and it's something that I wanted to use as a jumping off point with this piece. So here's kind of the process of what goes into making this thing. So it starts off with computer-aided design, but for me specifically, it was Illustrator, which is a 2-dimensional software that lets me use vectors to kind of map out sizes of things. And you can see overlaid over this robot is the Boston Dynamics robot. So I actually went with the size. This is around the size of a Boston Dynamics robot, and I really wanted to kind of create the same experience. But this is a very filtered version of what actually happens on my computer. This is actually what it looks like at this moment. It's very complicated, very messy. I'm happy to move on from it. So from there, I moved on to the 3D. So this is the software I use is Creo Parametric. And each part I individually model and put together in an assembly. And you can see it matches close to the real thing. And these are all the parts that I needed to manufacture myself. So here you can see we get two types of parts. On this side, there are the parts that are 3D modeled and very complicated and need to be manufactured with 3D printing. But then on this side, we have two-dimensional parts that I purposely made to be flat and able to cut out of various materials. So 3D printing, some of you may be familiar. I just take the 3D model file, and then I put it into my 3D printer, and like that, it's magic. It makes the part, but my printer is very old, so it's not quite magic. But for the flat parts, many of them on this robot are actually wood. So I would lay them out on a piece of plywood, put them into a laser cutter, and it would cut out the vectors for me. And this is great because when we think of robots, we think of metal, but in many cases, metal is too heavy and overkill for the purpose. I mean, you think of parts like this one and parts of the tail, to have them out of metal just doesn't make sense cost-wise, so wood comes in handy. But I was very excited. I actually do have a lot of metal on this robot. So I used my school's water jet cutter. So it's basically the exact same process as laser cutting, but I put in a piece of metal, aluminum, and it's a 1/4 inch thick, and it just shoots a bunch of water with some granite inside of it, and it cuts out these amazing looking parts. Unfortunately, halfway through cutting a lot of these parts that were going to be on this robot, they kind of caught me, because I've graduated already. So I go in, and he says, no. So that was tough. So a lot of parts on this, it's like this side is metal, that side is wood. It causes issues, but we worked past it. So then comes machining. So again, I'm using UW resources, even though I don't go there anymore. But you can see here and here, I'm using a mill, which is basically a spindle that I can move around and go down. And believe it or not, that's very powerful in machining. And then right here, we have a lathe. Not the best picture, but it basically spins a little stick, a little rod, and that's steel right there. And there are a lot of steel rods here that were cut to length on a lathe. And then another means of manufacturing I used was a manufacturing service in China. I basically 3D modeled this part to be made out of sheet metal. So it's much like modeling for 3D printing, except you have to specify bends. So a bunch of bends where they are. And so here are the leg parts. You can see them here, here, and then the back legs. Those are steel, and those are aluminum. Pretty awesome. And there you can see when they arrived. A little late, a little too close to the original date of this event, but they arrived nonetheless, and they do look beautiful. So electronics. These are the types of things where it's like, obviously I'm not going to make my own electronics. They have these that you can buy off of various websites, Amazon, a lot of these. Go Builda was another. So it's all about motors, Raspberry Pis, as I previously mentioned, hobby servo motors, Arduinos, voltage regulators, all these things that need to come together, be connected. You can see this mess of wires here. Maybe I'll present it because I'm quite proud of it. Voila. And that's my job, is kind of connecting all of the circuits together. I wish you could see inside of here. It's pretty awesome. So lots of that, lots of high voltage. Everything needs its own voltage. But then we come to the code. So there are a lot of different integrated circuits and computers on this to make it work. So I ended up having to use Python, Java, and C, all on different chips, some all running on one Raspberry Pi. And that was a very cool learning experience for me, because even though I've used those languages before, this is the first time I used robot operating system, which was a scary thing that I wanted to learn for a while, but for this project, it actually demanded it. So I took an online course to go through all the different ways of using it, and it's basically a way of communicating pieces of code running on a single machine all together at the same time. It's very powerful. And then image recognition. You probably saw the little boxes it was drawing around people, recognizing them. So there's a camera inside here, you might have known. And it has some autofocus, pretty cool. And it uses some trained data. So it pulled data from MIT's facial recognition library, and then it looks for patterns that match those images in that data set. And then from that, it finds little coordinates that I then draw onto the image that you were seeing there. So for animation, this whole thing that you saw here was pre-animated. So I used Blender, which is a free 3D animation software. And I basically have a skeleton that I keyframe. I use 20 frames per second. And I went through every frame meticulously, trying to make it look good. And then I convert it to 100 frames per second. And then, so every 100 seconds, the Raspberry Pi sends it to all other components, and they all are on the same clock. So this robot was originally made to walk. So the legs were pointed inward, and it was gonna kind of crawl on those legs. But it was a bit of a learning process. I'm still in the progress of making that actually work, up until like a week ago. So here's a couple first attempts at walking, still working on it. Let's play that video. Is that me, or? Come here, come here. Oh, damn. Ooh. Sometimes you gotta fight the robot a little. But yeah, it's a work in progress on that. I'm very excited because these motors are very strong, but a variety of things came together to not really make it possible, one of which being that annoying guy that didn't let me use that water jet to cut some of these parts. So we're working forward from there. We're gonna keep working on that. So along those lines, what are the next steps for Wiley? Well, literally, I want him to be walking around. I'm pretty optimistic about that, with some more time to kind of coordinate his motion, get him moving like that. And I want to make his movements more consistent, because the part that you didn't see about this is he doesn't know where his motors start, so I have to position them on a bunch of sawhorses, and then hit start and say, "You're right here, trust me," and then it goes from there. So in the future, I want it to be able to calibrate itself and have self-awareness of where it actually starts, not self-awareness in the AI sense. I want it also to be adaptive to his behavior. Everything you saw was animated, but it does have the capability with this camera to take in input. It can scan different markers on the ground. It has a lot of sensors on here that aren't really in use yet, but I'm very excited to get to applying their use cases. And then lastly, I definitely built this robot for performance in every aspect of the fact that it has these wheels and it's only meant to walk on a flat surface or move around on a flat surface. But also it's a very performative in its gestures. One thing you might want to know is about 2 hours ago, the head fell off because it fell because the battery ran out of battery. So there's like 9 zip ties right there that's holding that together. So definitely gonna work on that. But he's very expressive, so I'm very happy about that. And I think with the paint job, it already tells a story in its being. So this is just another robot in my arsenal of robots. I've got a writing robot, a drumming robot, and now I've got a creepy robot. And I'm very excited to continue growing that collection. Oh, and I'm making a build video. Part of the deal of why PCBWay made these leg parts for me for free was I would make a YouTube video about it, so subscribe. So I want to thank Town Hall for this amazing residency experience. From the very start, I felt so welcomed, and during Scratch Night, I felt like they were there for me, and when things weren't going well and we had to reschedule the first date for this event, they were more than welcome and more than accepting of that. They just wanted this experience to be the best possible, so big thank you to them. I also want to thank Ro Ramden, who's in the audience, who made those incredible sounds. I feel like that created the whole experience, so thank you for that. Also want to thank my girlfriend for letting me complain about my 3D printer a lot, because I'm very annoyed by my 3D printer right now. And mainly, I really, really want to thank and dedicate this performance to my parents, who, without their support, this wouldn't have been possible at all. They've been there for me every event. They come in, 10 hours beforehand. I've been here since, 8 a.m. with my dad, and he's just helped me hold the robot. So I thank them so much. And I thank you guys for all making it out and coming to see this performance. So I want to do a Q&A portion. I want to talk about this guy a lot. But you can clap first, and then we'll move on to that. I'm going to turn this guy off. His battery's running low, and I don't want him falling down again. Oh, that's another thank you I have to pass out. Sammy. Is Sammy here today? No. Sammy came up with that idea. Thank you, Sammy. It's kind of like Wall-E, but it's like Wile E. Coyote, and it's kind of like a coyote. So it all comes together. The acronym is also YL-E1, Wile-E. So kind of Isaac Asimov inspired.
What future builds do you want to do, and can I have a picture of him?
Yes, definitely. You can hang around, and we can you can get you on stage, and we can get you next to it. Sorry, what was your first question? What was that?
What robots are you planning to build?
That's a good question.
Future?
I've been so focused on this robot that I haven't. It's been making me sick thinking of other robots. But lately I have been very inspired about making robots that creep people out. I think that's that could be cool. Kind of like, I think a lot of these robots we have this idea of them being what sensors they do have and how they perceive reality. And in many cases, they don't see the world the way we do. So it's a good idea.
We've got a couple virtual questions. About how long did this entire project take, planning and all?
Yeah, so those sketches were 3 months ago. So from then till now, it was every day, you guys. Talk to my friends, that's all I talk about. And a lot of Wiley, he's kind of my best friend now. Sorry, guys.
You mentioned that you used 3 different coding languages. What were the reasons you needed to use different languages?
That's a good question. So Python is very handy for kind of the visual experience, what you were seeing with the Raspberry Pis are running Python. So all of the animation is being read with Python, but then C is being read by the Arduinos, mainly because they just only use C. But that C is really helpful for motor control. And then JavaScript was for what you were seeing projected there was actually like a web service. So it's being transmitted over Wi-Fi, and it kind of like it's drawing all those boxes like it's a website. So if you wanted, you could visit that website during the presentation. You could have seen it on your phone. Kind of cool.
Hello. You mentioned that Wiley has some sensors which you haven't really utilized yet. What of those are you most excited to put to use, and why?
Yeah. I mean, mainly it is just the camera that I really want to use to be able to like put markers on the ground and be able to like actually know its orientation, all that kind of stuff. But then the other aspect of it, which kind of goes unnoticed when you look at the like Boston Dynamics robots, is their motors themselves have like backdrive capability, which means when they're getting like pushed in, they know it. They can feel that pressure. So same with this robot. It can feel the pressure, and theoretically, it could know whether or not its leg has touched the ground or not. So that's what that adaptive comes through. So it's like, what if I step onto a crack on the stage, which would have been devastating for this current state of the robot, but has the potential to not be devastating.
Why is it important for you to approach robotics from an artistic viewpoint?
That's a great question. Number one, it's a lot of fun. I think I have always been obsessed with robots. And for a while I was like contemplating, I was like soul searching, why am I so obsessed with robots? But there is no reason, I'm a robot boy. But I think already it just fascinates me that we can make moving sculptures, moving beings that we can think that are alive. Like that's one of the most important, not important. Sorry guys, not important. For me, it's one of the most powerful ways of presenting art, because it's magic. Speaking of the black box, this is our world, our universe's magic, in my opinion, is technology. So I think by using that, harnessing that, and all this technology that I can just buy on Amazon, I think that's an incredible time to be alive, and we ought to use that opportunity to make cool things like this.
What's the function of the tail? Because I see it has some device on the end of it.
Yeah, so this is an infrared transmitter right here that's blinking, which was, when it was in there, it was kind of transmitting, it was kind of shaking the box. I don't know if you guys noticed that, but there's a little motor in there shaking the box, kind of cool. And this is the battery. It's actually like a DeWalt battery from a power tool. But it turns out those are very good at delivering a lot of energy very quick. And then this is like a way of being smart about the battery, so it knows when to shut off, which was the cause of why it fell down earlier, but it's still very smart. And then this is also another battery pack for powering one of the Raspberry Pis. And these are zip ties, currently holding the tail from hitting the ground. But there is a motor here that does swing the tail, but I wasn't going to do that tonight. Sorry, guys.
Any plans to implement adaptive AI into Wiley?
Yeah, I mean, I think the topic of AI is very interesting and how it fits in with technology and technological art. And when I kind of like, during my interview for this residency, I was like, yeah, I'm gonna use AI, you know, it's a hot topic, but it honestly doesn't like interest me a lot. So I was like racking my brains, like, how can I make something that interests me about AI, but it's not very interesting. So for me, the limit of my interest is with computer vision and these kinds of issues that I can't come up with a solution with, but the AI can. So I don't have much like interest in like language models and implementing those into robots. I don't love talking robots. Not a big fan. But I think as AI gets more powerful, I think we'll get to see more interesting ways. Like robot operating system has this whole way of using AI to run a whole simulation of your robot, so it knows it can train, you know, train situations before it even encounters them. So I think that's very powerful.
Did Wiley complain a lot, or was he pretty cooperative through the design process?
Not cooperative at all. That is why there's zip ties on that tail. It would be like, first of all, it's 48 pounds. This whole time I've been like, oh, you know, it's probably around 20 pounds. I weighed it last night, and I was like, 48 pounds? Like, that's why my back hurts. So whenever I pick it up off the sawhorses, it would like swipe my desk, and everything would fall off my desk. So not cooperative at all. We made up, we're friends, it's good, but definitely could have helped out a little bit more.
The design is really cool. Are the spines and other extremities all functional, or are some things just cosmetic?
Yeah, everything is functional. So this is like a emergency stop, which I can press because it's already off. But there's control the motors for the arms. In case something goes wrong, it starts attacking people. These switches are switches. So this one does like the amplifier for the speaker, and then this one does the tail and the little fan on its head, and the others do like more data modes kind of. But everything else, yeah, it's all functional. I'm pretty proud of that. I think with my other robots, sometimes I do, you know, take some creative liberties with the bits and bobs I put on them. But with this one, it's very form from function. Yeah.
Okay. What animals inspired the movement language of Wiley?
Mainly coyotes. It's very cool. I think like whenever you see a coyote in the middle of a street, you're kind of like, what? Like those things moving around, like. Because like it's kind of uncanny valley. You're like, is that a dog? Is it not? So mainly coyotes. I think they're a little creepy. But I think in general, I did want to create a creature that was something of its own. You know, you wouldn't be like, oh, it's a robot dog. You know, I wanted it to be its own creature. So I think in that, I learned its own behavior from creating it and experimenting with it.
I coach a group of young engineers, 5 to 10 years old, who would love to know your advice for what they can learn or do to also have the capacity to build adaptive robots?
That's a great question. You're not going to learn it in school. You got to learn it by yourself. I think that what's really important is finding projects that you're passionate about. And obviously, the way to start, this is very concrete, buy an Arduino starter kit for your little young one. And they're going to love it. It's very fun. It's very addictive. You make a little LED blink, and you're thinking, I can make a lot of LEDs blink. I think it really does come down to, you don't have to worry about the scope of the project. And when you're young, you'll start a project, it'll go nowhere, and you move on, and that's how it works. And it's all about learning what you need to learn to make the art you want to make.
I noticed with this one and the drumming robot, you like to have a pretty worn exterior. That makes it look like it's aged a bit. I was wondering what the inspiration was for that and this one in particular.
Yeah, thanks for that question. Because with my drumming robot, it has like graffiti on it and has rust on it, and I wanted it to seem like it's a robot that's been, left to its own, out in the world, and it's. But then with this one, I wanted it to be more about a robot that's been through a lot, a robot that's still functional. It still can do its job, but very much has seen some stuff. So taking inspiration from excavators and tractors, I wanted to make it like dirty, like it's been in mud, and a lot of worn down. It was a lot of fun to like paint it all yellow and then scratch off with my keys to make it look like it's been scratched up a bunch. So I definitely wanted it to tell a story with its aesthetic, because so many times, like the Boston Dynamics robots, it's these pristine robots that almost seem unreal, uncanny, because you think nothing in my everyday life looks this pristine. So I wanted it to seem a bit more approachable.
You were saying like the power tool battery thing is a common thing in the robotics world. Whom do you follow in creative robotics, and who are you inspired by right now?
There's one guy. What's his name? He made body sculpture. Look that up. Body sculpture. It's incredible. And I really just inspire myself, But I really think for me, like one of the more powerful ways of expressing media is film and science fiction for me, and seeing science fiction robots growing up, I think that's been very inspiring to me, like Star Wars and various sci-fi movies, 2001, shout out, everybody, go watch that one. So I think it's been more about media that I've consumed.
Hello. So I really liked what you said about how, like, when you get your first Arduino and you make a light bulb blink and you feel like you can do anything. And so I was just wondering, what was like the first thing you got to work on this that really made you feel like you could actually do the project?
That's a very good question. I think back to when I started this project, and I think I was insane. Like, I definitely couldn't do this again. What was the first thing? Oh, it was just all the electronics in the middle. Very boring, to be honest. It was all the voltage regulators, wiring them all up, making sure I could get all the different voltages, because like they're so picky, electronic components. They're like, I need exactly 5.1 volts or I'll explode. So I have a bunch of different voltage regulators. Pretty boring answer, but I think the more fun aspect was the machining in the early process, It'd be like little different parts that would be like this part on the arm, but machining for me is always very therapeutic. So that was a very fun process.
So I have a couple questions. They're short. The first one is, did you say that Wally came from conception to today in 3 months?
That's correct, yeah.
That's impressive. Okay, one
Thank
second.
you.
That's impressive. Okay. Okay. Second is, do you have an SSD drive on there, or is everything sent up to the web?
Yeah, it's pretty much all locally run and locally like local memory, but I do a lot of the like animating on my my own computer, and then I transfer the files over like a remote desktop. So I log on to these computers on my laptop, and I see what they have, even though they don't have a screen. It's all very, conceptual, and yeah.
So can Wally go back into her box and shut it on her own?
No. Yeah, I'm sure as much as he would want to, he's stuck on the ground right now and has no means. And I probably shouldn't say this, but I spent 100 hours, no, I don't know, somewhere between 20 and 100 hours trying to get this guy to turn. He can't turn, so hence you saw him go forward and go backwards. Because he wasn't built to drive around. But hey, we made it work. Do you want to clap again?
And finally is, Wally is obviously a prototype, so are you going to improve on Wally, or are you going to create a different prototype?
Mm-hmm. That's a good question. Yeah, I definitely just keep going on this robot. So it's kind of like, there are no aspects of it where I'm like, we got to overhaul the design. I definitely learned a lot from it, but it's kind of like a swap apart, and then it's the ship of Theseus. Is even the same robot in the end? But right now I'm very obsessed with Wily. I can't think of anything else other than Wily, but I'll probably start on a new robot eventually.
Sort of a follow-up to an earlier question. If you were to implement adaptive AI, how would you filter and store the new data it would be consuming?
Yeah, that's an interesting question. That's the one thing that I've been thinking about is, I don't know if, I guess it would be considered AI, but I do love the idea of memory in robots, because every time you turn on a robot, it's a new being. It has no memory of its past boot ups. Even if it has AI, it's on pre-trained AI. It's not its own experience. So I'm obsessed with the idea of making a robot that records everything that it's seen and doesn't let go of that data, because I think that would be very cool, getting closer to an actual robot friend, remembers my face.
If we've got no more in-person questions, I've got a good virtual one to go out on, so last chance. Okay, good. Now that Wily is built, what would you have done differently if you had more time, money, space, any resource you could imagine?
Metal. Make everything out of metal. And if I had more time, this guy would be dancing around, he would be. I had visions for this. I had a whole storyboard for what I wanted to tell with this project, and I very much want to still explore that and explore that performance that I have written out. So, from now, I very much plan on pursuing that. Oh, good question. Good question. No, and heaven.
So how can people track your progress with Wily and with any of your other projects going on?
Yeah, definitely YouTube. Guys, follow me on YouTube. And I make build videos. I already got some videos up there. I'm kind of funny, I'm kind of silly in those videos. And I'm going to make a build video about this. I also plan on, when I make that future performance, I'm going to kind of record it to be all pretty. And I want to make a lot of videos. Oh, also my writing robot video coming soon. Don't you worry, you guys.
Amazing. Well, thank you so much for showing us your hard work that you've done over the last 3 months. I know Bailey's going to be kind of hanging out on stage if you guys want to get a closer look at Wiley before he goes back into his box. But thank you all so much for coming, and enjoy the rest of your night.